Hello everybody, I'm going to try something a little different. I'm going to take my video over here to this lovely wall that I have, that's just the second unit. And this one down here is what we're going to be talking about today is functions, and I know you've learned this before, but functions are when the x's don't repeat. The very formal definition is for each x input, there is only one y output. X's are the numbers that we do the math to, and the y is the number that gets spit out of the equation. So x's are your inputs, y's are your outputs. So sometimes they will say it with just for each x, there is only one y, or they'll say for each input, there is only one output. But that's what makes it a function when the x's do not repeat is the more informal way we say it. And then we're going to be talking about, whoops, let me get up here, function notation. F of x equals means your y equals. So f of x is just a fancy way to say that's your y and that's your equals. In your calculator, the Inspires, it will say f of x equals, and that's just simply your y equals part of the equation, and then you would type in the rest of the equation. So we're going to be talking about all this stuff here today. So these are the posters, and there will be a link to your posters in the assignment. And of course, they're in the resources also. So let me put this back up here. I forgot to put my headgear on, so we're going to try to do this without that today. I'll try to talk nice and loudly. So this is your worksheet, and of course, at the top of the worksheet is that formal definition we just talked about. A relation just means there are two things, an x and a y. We're graphing them on a coordinate system that has an x-axis and a y-axis, so we are comparing two things. That's a relation. So a relation is a function, so fill in that blank with the word function. If you're at home doing this, you're just going to simply write this sentence on your paper. A relation is a function if each input or x value has only one output or y value. Okay, so it reads a relation is a function if each input or x value has only one output or y value. So inputs are your x's, outputs are your y's. And what does that mean specifically? Well, we're going to do it in a couple of different ways. We're going to tell something is a function from a graph, from a table, and from a set of ordered pairs. And so basically, if it's a table or ordered pairs, you just look at the x number and see if it's repeating. If the x number repeats, it is not a function, okay? So we're going to do these down here first, and we'll come back up here to the pictures. So let me slide this up just a little bit. There we go. So if we're looking at tables, now you do not copy all the stuff down in your paper. You can just simply say the directions are a circle, the graph, table, or mapping that represents a function. So what we're going to do is you can just write down your papers the ones that are functions. So if graph A is a function, you will write, you can abbreviate it GA. If GB is graph B is a function, you can just write GB on your paper. If it's not, then don't write it on your paper. So we'll come back to the graphs in a second. Let's do the tables first. So table A, do I care about the y numbers if I'm looking to see if it's a function? No, don't care about the y's at all. All I'm focused on are the x numbers only. And I just go down the list of x numbers and see, did any of these repeat? -7, -4, 1, and 9. None of those numbers repeated, so yes, table A is a function, and you would write table A on your paper, or write yes next to it if you want to. Table B, don't look at the x numbers, don't look at the y numbers, could care less about those if I'm looking at functions. So just look at the x numbers only. -0.2, 3.4, 2.3, 4.8, and 6.2. None of those numbers repeated, so yes, table B is a function. So you could just write down the ones that are functions and leave off the ones that aren't functions, or you could just write down TA, yes, TB, yes, and then TC, whatever it is. Table C, don't look at the y's for a function, we just want to focus on the x's only. I have a 6, a -3, oh, 6 again. Did the 6's repeat? Yes, they did. If they repeat, are they a function? No. So you would not write table C as one of your answers, or you could just write no next to table C if you want to do that. Now, how do we do the same thing when it's a picture? The easiest way to tell if it's a function is to do what's called a vertical line test. Vertical lines are straight up and down, right? Straight up and down lines. Not a horizontal line test, a vertical line test. And what we do is we pass this vertical line across the graph. And so my graph is this little line that does this. If I'm only touching one point at a time, only touching one point.
Hey, good morning.
Hey, good morning.
Were you able to test everybody yesterday? Are you still?
No, we have third period to do
You
that.
still? Okay.
Yeah. Sorry for that interruption, everybody. Here we go. So we're doing this vertical line test. And so if I look at it, I'm only touching one point on my graph at a time, until I get right there. See this part right here that has the straight up and down line? There's a point. I am touching more than one point at that place. So this one is not a function. I can get my marker on there. So this one is not. Because of this section right here, I have got more than one x, that number x right there, I think it's a 2, has got that y number, that y number, that y number, that y number. So 2 is used over and over and over if we were to make a list of the points out of that. But anyway, so if it passes the vertical line test, it is a function. If it has more than one point touching the vertical line, it is not a function. So this is a no. So let's look at this one. If I do my vertical line, I come across here, I'm only touching 1 point on that vertical line, 1 point on that vertical line, 1 point on that vertical line. Oh no, there are 2 points, one up here and one down here. So since there are 2 points touching it at the same time on a vertical line, this is not a function. So graph B is also no. So the vertical line test is a way to do that. And the reason is, right here, this number is 2, and this ordered pair would be 2, I can't really see the numbers, but I think it's 2, 4, and this one would be 2, maybe -6 or whatever it is. But notice there's a 2 is for the x and a 2 for the x. So that's why it doesn't work if they're lined up vertically. They are both using the same x number, and that is not a function. Vertical line test over here. I just slide the vertical line across, only touching 1 point on the graph at a time, 1 point, 1 point, 1 point, 1 point, 1 point, 1 point. Hey, this one is a function. So if they give you a graph, you do a vertical line test. As long as it only touches 1 point along that graph, you are a function. If it touches 2 or more, then it is not a function. Okay, so we're done with the tables, done with those. Let's move down to the mapping. Mappings are slightly different. It's still the same concept, it's just that they look different. And here's what a mapping looks like. These are mappings. So I have mapping A, B, and C. The first is almost like a table, except it's not quite a table. The left side is your x numbers, the right side is always the y numbers. So just like in the table, x's are on the left, y's are on the right. The arrows indicate what points are being paired up. So this -2 to 5 is saying I have a -2 and it's being paired up with 5. This one says 3 is being paired up with 4, so 3 is being paired up with the 4. The 6 is being paired up with the 5, and the 9 is being paired up with the 4. So it's just another way to show a table, except it's done this way. So what you look for is, again, don't worry about the y numbers, just look at the x's. Is there only one arrow on the x number? Only one arrow coming from the x number, only one arrow, only one arrow. That means those numbers are only being used one time. If they were only being used one time, they are not repeated, so yes, this one is a function. So let's look at the next one over here. Again, we're looking for a function, so don't worry about the y numbers. The x number 0.5 has one arrow coming from it. It's being paired up with one number, and that's it. 1.6 is being paired up with 0, but it's also being paired up with 1, so this is like having 1.6 with 0 and 1.6 again with a 1. So did my x's repeat? Yes, they did. Is this a function? No, map B is not a function. So that 2 arrows coming off of there tells you that 1.6 got used twice, so they repeated, not a function. Mapping C, what do we think on this one? Did the 4 get used one time, or is it being used 3 different times? Yeah, there are 3 different arrows coming from it, so 4 is being used 3 different times. Is that a function if the x repeats? You're right. That one is not a function. Okay, so that's how you do that. So let's look at the little notes at the bottom. We're going to fill in our notes. Our little summary of what we just figured out by doing this. I can determine if a graph is a function by doing what kind of a test? What do we call this? It is a vertical line test. You're going to slide it across, right? So the answer here is I can determine if a graph is a function by doing a vertical line test. All right? If it only touches 1 point, it's a function. I can determine if a table is a function by looking at what? The x's or the y's? Yes, the x's. You look at the x's, and if the x's repeat, not a function. If the x's don't repeat, it is a function. So there's how you can do it from a table. I can determine if a mapping is a function by, I'll only look at the x and I look to see how many arrows are coming off. If there's only one arrow coming from each x number, it is a function. If I have more than one arrow coming from a single x number, then it's not a function. All right, so there's your information for those. Let's look at the second page. So that was our function information. The second one is about function notation. So page 2, new information, here we go. Function notation, let's blow this up some. Okay, so function notation, some people say, why do they do it instead of leaving it just y equals? It's a shorthand. This lovely f of x equals. This just means y equals. So every time you see f of x, or it could be g of x or h of x or some other thing, what happens is people had more than one equation when they were working with stuff. So maybe they had 3 or 4 different equations. So you had y equals, y equals, y equals. Let's say it was 3x plus 2. Maybe I had x squared. Maybe I had an x minus 1. I had 3 different equations. And the guy would say, oh, go plug it in the y equation. Well, they're like, well, which y equation do you want me to plug it into? So they just came up with a way to letter the equations. So they can make it f of x. Maybe make this one g of x, and that's how you pronounce it. Maybe they made this one h of x. So now I have an f equation, a g equation, and an h equation. So it's just labeling the different equations so you know which one that you're working with. So f of x is just another information for y. So anytime you see f parentheses x closed, that is pronounced f of x, g of x, h of x. You might want to try saying that out loud so it doesn't sound funny when you actually do it sometime. So h of x. It's just a labeling system for that. So just remember in your head it's y equals. That's why in your calculator, the Inspire, it says f of x equals in there already. So that part of the equation is already in, and you would just put in the right-hand side of that equation when you're using your Inspire. All right, so let's go see what this actually wants us to do now. Now that we know what function notation is, it's just a shorthand for labeling a bunch of equations. Now up here it says f of x is equal to x plus 3. So this is one equation, right? And it says g of x is equal to x plus 2. So there are 2 different equations up there. There's an f equation and a g equation. So when they say f of 3 equals, what they want you to do is it's a plug and chug. Notice inside this, I'm going to put this big for just a second, f of x. Notice inside the parentheses is what letter? X. Inside this f of 3, the 3 is inside there. So these are identical except where the x is, there's a 3. So what do you think they're substituting in for the x? Yes, the number 3. So what we're doing is taking this equation and plugging a 3 in where the x is and just doing the math and seeing what y is equal to. So let's do that on this first one. The equation up here is x squared plus 3. And it's f, that's f. So x squared plus 3. My tip to you, and this is a huge tip, wherever you see the variable when you're going to plug something in, you make it a parentheses. Okay, when you write it down as a parentheses, this is x squared, I put parentheses squared plus 3. The number that we're dropping in for x is a 3, so I'm going to put the 3 inside there. All we have to do is do this side, and we will know what this is equal to. So, 3 squared, 3 times 3 is 9. 9 plus 3 is 12. So this is saying f of 3 is equal to 12. If you wanted it as a table, it is saying when x is 3, my y is 12. Okay? Or we can make it into an ordered pair. When x is 3, my y is 12. All we're saying, but that's what we're letting you know is that you're finding a point on this particular equation. So 3 comma 12 is a point on that equation. So f of 3 is equal to 12, and you do that by plugging and chugging. And again, you can put this part in the calculator, just the basic, calculator. You could go to not a graphing calculator, but the actual math portion, and just put this right-hand side in and just have it do the math and spit the number out. Okay, g of 3. So g of 3 is saying use the g equation. So I'm going to use this equation, and that is x plus 1. So x plus 1. Notice I put parentheses where the x is. What number are we substituting in for the x? 3. 3 plus 1 is 4. So g of 3 is equal to 4. So in the g equation, if I was making a table for that equation, when x is 3, my y is 4. I don't need to make the tables on your paper right now. I'm just showing you what this means. When x is 3, the y is 4. Okay, so all you need to do is tell me this, show the substitution, and write the answer. All right? So you don't have to show extra tables and things. We'll get into that in a little bit. I just wanted to show you something about what the whole thing is doing. So now f, which equation are you using? Make sure you pick out the right equation. This is the x squared plus 3. X squared plus 3, drop in what number? Negative 2. If you do not put parentheses around this and put it in the calculator without the parentheses, you will get the wrong answer. So make sure you use those parentheses. I'm telling you, it will keep you from making a mistake. So 2 squared is negative 2 squared is negative 2 times negative 2, which is a positive 4, and 4 plus 3 is 7. And again, you could do these by just putting the right-hand side in the calculator, just the plain old add subtract stuff. G of 0, we want to know what it's equal to. So they want to know when x is 0, what is y? So use the G equation, and that's x plus 1. X plus 1. X is a 0, so substitute a 0 in. 0 plus 1 is 1. So when x is 0, my y is 1. F of 2, use the F equation, plug it in. G of negative 1, do those two, see what you get. You can check them with the answer key later, but I want you to make sure that you can do these. So I'm going to move on to the next section. You guys can pause, do that, and then turn the video back on. Moving to the next section here. These are asking us, what is the value of f of 5? And notice that they gave you an F equation, didn't they? So all they're saying is, what are we going to plug in for x? Remember f of x? X is there, the 5 is in the parentheses, so they're taking the 5 and plugging it in for the x. So you're going to take the right-hand side and plug that in. Remember to use your parentheses, it's like you just did on the last problem. X squared minus 3 times x. So here's my x squared minus 3 times x. I put parentheses where the x's are. Drop the number inside. What is my x number? 5. Do that math and find your answer. Y'all go do it. I'm not going to tell you. It's on the answer sheet. You can check it later. This one, same thing. What is the value of f of negative 6? They gave you another f equation. So for this equation, find f of negative 6. So again, write down the side where the x is, make yourself a parentheses, drop the number inside, and just go do that math. Okay? So this is just knowing the shorthand, the shortcuts that mathematicians use. And once you know what the symbols mean, the math becomes really easy. All right, let's move down to the bottom section. This one. This time, it's a big old table, so again, you don't need to copy all this stuff down. Oops, I'm going the wrong way. You do not need to copy everything down. What you're doing is they've given you a picture of an F equation, they've given you a mapping of a G equation, and they've given you a table of an H equation. So I'm going to make those a little bit bigger so we can see them. This one is F, this is G, this is H. And then down here, they want us to fill in this function notation. They want us to give it as an ordered pair version, and then they want us to do it in a verbal statement. So all of these are saying, when x is this, the y is that. When x is this, the y is that. When x is this, the y is that. So you can make yourself just a little table, just a 3-column table, and you can put h of 3 equals, and then tell me what it is. So this is my h. So I'm going to go find h. So h is over here, it's a table. It says h of 3 equals. The thing inside the parentheses, is that my x or my y? It's the x. So x is what number? X is 3. So over here, let's see when x is 3. Right there. When x is 3, what is my y number? 3. So this is saying when h of 3 is equal to 3. When x is 3, the y is 3. The ordered pair, x is a 3. The y number is a 3. That's that point, 3, 3. If x is equal to 3, then the value of h of x, which is y, I'm going to put a big y here so you don't forget, y is also equal to 3. So when x is 3, y is 3. When x is 3, y is 3. When x is 3, y is 3. It's just the same thing in different formats. Function notation format, ordered pair format, verb words. F function. So here's the F function. These are a little bit tricky to read. They don't give me any information here, do they? But they did tell me over here, what is the x number? X is 1. So when x is 1, when x is 1. I can go ahead and fill in the x's. 1, 1, 1. All 3 x's are 1. So they want to know when x is 1, what is the y number? So let's come up here to this graph. X's are here. So when x is a 1, here's 1. I'm going to go down to the graph and see what this point is. This is the point we want to find. Because that point has that start. It goes over 1, and I want to know how many down I went. And it looks like we went down -3. So there's my point. 1, -3. That means when x is 1, my y is -3. When x is 1, my y is -3. It's just the same thing over and over, just doing things from a graph or a mapping or a table. G is our mapping one, right? Nothing, no information here, no information here, but they say x is equal to what? 3, and they're telling you y is equal to 0.5, so that's easy. 3.5, right? When x is 3, the y is 0.5. That's the point. When x is 3, y is 0.5. And here it is up here. When x is 3, the y is 0.5. So when g of 3 is equal to 0.5, because when x is 3, the y is 0.5. So this is a little sneaky way to give you an ordered pair. They give you the x number, they give you the y number. Who would have thought? Shorthand, mathematical shorthand. G of -3, this is the g one. So here's the g. I want -3. When g is -3, what's the y number? 0.5. So when g is -3, my y is 0.5. When g is -3, my y is 0.5. So go ahead and finish off the rest of that. You got the answer key to check it against. Bye.